NASA's airborne surveys are giving scientists astonishingly accurate views of how Greenland's glaciers are changing. Laser altimeters map the very details of glacier surfaces, and flights spanning 2 decades reveal the dramatic changes that have taken place. On Greenland's rugged eastern coast, spilling into a mountainous fjord, lies the 4-mile-wide Helheim Glacier, named for the Viking world of the dead. It's had a wild ride over the last 20 years, first rapidly retreating and thinning, then partially recovering its former extent. NASA science missions have flown the glacier's center line year after year, collecting a wealth of valuable data. It all begins with a single beam of light. Firing several thousand pulses per second, laser instruments onboard research aircraft measure the height of the surface below. The lasers spin in a 250-meter circle, providing a swath of data that can be turned into a topographic map of the ice. Here, we've shown higher elevations in red and orange, and lower elevations in green and blue, all the way down to the glacier's calving front, where Helheim's mighty icebergs break off into the sea. But one snapshot only tells part of the story. Here's a 1998 swath compared with 2013. We've changed the color scale to highlight the local differences in elevation. We're now moving below the surface of the ice as it was in 1998, and over the melange of icebergs and ocean that was present in the same spot in 2013. The calving front of the glacier has retreated significantly, by 2.5 miles. The glacier has thinned as well. We couldn't have flown at this elevation 15 years ago. This all would have been ice. NASA's Operation Icebridge, which has been measuring Greenland since 2009, has added to the laser data from previous missions with new instruments, like ice-penetrating radar, a magnetometer, and a gravimeter. It's also used a high-resolution camera system, taking overlapping images of the ice throughout its 8-hour flights. These images can be pieced together into a mosaic, and since they overlap, provide us with a stereoscopic view of the ice and an elevation model of their own. Here is that model overlaid onto the laser data as we approach Helheim's 70-meter-high calving front. As we get close to the glacier's terminus, large cracks in the ice, called crevasses, get longer and deeper. A sign new icebergs will soon join their comrades on their way out to sea. Until the launch of a new NASA satellite, ICESat-2, Operation Icebridge will return to Greenland every spring to continue measurements of this large and ever-changing glacier.